All right, so this section covers 2.1, and as we start this new chapter, the first thing that we're going to go over is all the different ways of operating on complex numbers. So before we get into adding, subtracting, multiplying, and dividing complex numbers, let's talk about what they actually are. So the first thing that I want to talk about is this idea of an imaginary unit I. So I want to draw your attention back to a particular equation that you may have encountered in the past. So say we have x squared equals -4. And in order to solve this, we would, square root both sides. And then in the past, you would have come to the conclusion that we cannot have a negative underneath the square root, so therefore this is no solution. All right, so then mathematicians said, well, I want to really be able to, talk about solutions where we have a negative underneath the square root. So they sort of created this imaginary I unit. So we're going to go ahead and define the imaginary I to be the square root of -1. Okay, so anytime you have a negative underneath the square root, that is going to come out of the square root and going to be I. Okay, so let's talk about some other operations of I. So let's talk about I squared. So if we have I squared, then essentially what I'm doing is I basically have I times I, and if our I is the square root of -1 times the square root of -1, then our square roots are going to cancel and we'll just get -1. So these are the main two that you need to be familiar with. So I, we define as the square root of -1, and then I squared is going to be -1 without the radical. Okay, so this is the imaginary unit. All right, so now let's talk about this idea of complex numbers. All right, so the first thing that I want to say is that when we are writing something in standard form in regards to a complex number, that it is going to look like A plus BI. So every answer that you have in dealing with complex numbers should always be in this format. So A plus BI. So let me talk about a few things here. First off, this A is the real piece of the complex number, and this BI term is the imaginary piece. And together, they make up this complex number. So I want to be clear here that A and B are real numbers. Okay. All right, so when I have this A plus BI together, it's a complex number. So essentially a complex number is this real and imaginary piece put together. All right, so let's say that B is equal to 0. So if B is equal to 0, then I have A plus 0I, which essentially is just A. If my I drops out and I have no more imaginary part, then this just becomes a real number. All right, and then say, what about if A is equal to 0? Okay, well then I have 0 plus BI, which is just BI, and notice that the real part of this drops out. So this is known as a purely imaginary number. Okay. So I sort of wanted you to kind of understand that, if I have A plus BI, that becomes a complex number. A is the real part, BI is the imaginary part. And then if one or the other is equal to 0, then I would have either a real number or I would have a purely imaginary number. Okay? All right. So let's go ahead and talk about how to write things in standard form in example 1. Okay, so notice that I have 6 minus the square root of negative 4. All right, so if something is going to be in standard form, then I need to put that in a plus bi format. All right, so what we need to do is we need to rewrite the square root of negative 4. So here's how I want you to think about this. This is going to be 6 minus the square root of negative 1 times the square root of 4. So essentially I'm pulling out the negative from 4 and separating it into its own radical. All right, so now the square root of negative 1 is defined to be I, so we can now replace the square root of negative 1 with I, and the square root of 4 is going to be 2. And so now we can just write this a little nicer, so this is going to be 6 minus 2i. And notice that it's now in the a plus bi format, so that is our number in standard form. Okay, so let's try to tackle part B. So notice now I have two different radicals, the square root of 2 and the square root of negative 50. All right, so I don't know if any of you are considering sort of multiplying those two radicals together and getting the square root of 100, but we actually can't do that. So if we go back to this property that said the square root of a times the square root of b is equal to the square root of a times b, this property only works if a and b are greater than or equal to 0. So if these two numbers underneath the radical are negative, then this property does not work. So we have to solve it using actually the same strategy that we did in part A. So I would have negative 7 plus, and now I'm going to take out the negative from radical 2. So I'm going to have the square root of negative 1 times the square root of 2. And then I'll do the same for the square root of negative 50 and separate it as the square root of negative 1 times the square root of 50. All right, so both of my square root of negative 1s will simplify to I. And then now notice that I have the square root of positive 2 times the square root of positive 50, and now I can use that property and combine them. So I will get negative 7 plus, I will have I times I, and then when I combine those two radicals, I will get the square root of 100. So as we keep simplifying this, this becomes negative 7 plus I squared, and then the square root of 100 is 10. All right, so again, my goal is to get this to be an a plus bi format. So notice this I squared poses some problems because I need it to just be I. So we actually defined I squared to be negative 1 in the above box. So now I can take out I squared and I can plug in negative 1. So this is going to be negative 7 plus negative 1 times 10, which essentially is negative 7 minus 10, and so this simplifies to negative 17. And if I wanted to write this in a plus bi format, it would be negative 17 plus 0i. So notice that my I dropped out, it's no longer there. So this actually simplifies to a real number without the imaginary unit in it. Okay, so those are a couple of examples with rewriting numbers in that a plus bi format. Okay, and again, that's that format that you always want to be working in. All right, so let's talk about a couple of these properties. All right, so first off, equality of complex numbers. So the first thing that I want to say here is that if I have two complex numbers equal to each other, so say a plus bi, that's one complex number, is equal to c plus di, that's the second one, then I can actually make the conclusion that the real stuff is equal to each other, so that would be a and c, so those would be equal. And then the imaginary pieces would be equal, so that would be b and d, and we know that I is equal to I. So essentially this is bi equal to di, which implies that b is equal to d. All right. How about addition of complex numbers? So say I have one complex number, a plus bi, and I'm adding it to a second complex number, c plus di, then essentially what you do is when you're adding two complex numbers, you just add like terms. So add the real stuff together, which is a plus c, and then add the imaginary stuff together, which is bi plus di. So you add the real stuff together, then you add the imaginary stuff together. All right, for subtraction, it's very similar. So now I'm subtracting these two complex numbers. So again, just subtract like terms. So we're going to subtract the real stuff, and then we're going to subtract the imaginary stuff. So again, really it's just combining like terms. Combining like real stuff, combining like imaginary stuff. When I'm multiplying two complex numbers, then you just approach this with the same strategy of foiling, and then remember that I squared is equal to -1. And so that will be important here as we do a couple of examples. Okay, so let's look at example 3a. Notice that I am subtracting these two complex numbers. So again, the first thing that I like to do is to distribute the negative. So we're going to get 5 minus 11i minus 7 minus 4i. And if you distribute that negative first, then now you can just look at the like terms. So combine the numbers, which is -2, and then combine the i's, which is -15i. And then notice it's in that a plus bi format, which is the answer that, or the format of the answer we're looking for, so we're good to go. All right, so part B. All right, so this is multiplying. And notice that I just have this one term out front, so we're going to use the distributive property. All right, so we'll get 10i for that first term, plus, and then now just multiply the like stuff together. So 5 times 3 is 15, and then I times I is I squared. All right, so again, I want my answer in a plus bi format. So this I squared poses a problem, but what we can do is we can replace it with -1. So we take it out and we substitute -1. So I'll get 10i plus 15 times -1. And so when I write this in a plus bi format, it becomes -15 plus 10i. Okay, part C. Okay, the first thing that I want you to notice here is that this particular complex number, -3 plus root -9, is not in a plus bi format. So I have to get it there first, using a similar strategy that we did in example 1. So what we want to do is we want to take out the -1 from the radical and separate these two ideas, and we know that the square root of -1 is I, so this becomes -3 plus 3i, as the square root of 9 is 3. So essentially I'm taking this complex number and I'm adding it, or subtracting it, from the first one. All right, so I'm going to follow the same strategy I did in part A. Let's distribute the negative. So 2 plus 4i plus 3 minus 3i. Okay, so plus 3 minus 3i. Now we combine like terms, so 2 and 3 is 5, and then 4i minus 3i is just 1i. So 5 plus I would be my answer in the standard format that we're looking for. Okay, part D is multiplying two complex numbers together. So all we do is FOIL. So 4 times 2 is 8. 4 times 3i is 12i. Negative 3i times 2 is negative 6i. And negative 3i times 3i is negative 9i squared. Okay, so do two things. Combine the I stuff together and then replace I squared with negative 1. So we'll get 8 plus 6i minus 9 times negative 1. Okay, so now notice that I have 8 and positive 9, so we'll combine those to get 17 and then plus the 6i. And so notice I'm just kind of simplifying to get it down to that a plus bi format. Okay, the next idea is something called the complex conjugate, and then we're actually going to use it to be able to divide two complex numbers. Okay, so this is the last operation. So we've done addition, subtraction, multiplication, and then now let's talk about division. So a complex conjugate. So if I have a complex number of a plus bi, then its conjugate is going to be a minus bi. So similar to, when we did radicals, okay, so something that, you may be familiar with is something like 2 plus root, 4. And when we had that on the denominator, the conjugate of this was 2 minus root 4. Okay, so this is very similar to that. So all you do is change the sign in the middle. And we're going to use this complex conjugate to be able to divide two complex numbers. So first in example 4, it just says find the complex conjugates of the following numbers. So here we're just kind of figuring out what they are. So for part A, it would be negative 3 plus 2i. For part C, it would be 4 minus I. And then B and C are sort of the special cases. So if I rewrite 5 as a complex number, then it's 5 plus 0i. And then if I change it, the conjugate would be 5 minus 0i. So notice the 0i doesn't really matter, and so the complex conjugate is still 5. It's still that number. Okay, if we do part D, then if I write it in standard form first, it becomes 0 plus 3i, and so the conjugate is 0 minus 3i, which would be equal to negative 3i. Okay, so just be aware of those special cases when either the a or the b value in the complex number is 0. Okay, so when we're dividing complex numbers, so if you look at example 5, we have 5 plus I divided by 3 minus I. And sort of like radicals, we can't leave radicals in the denominator. This is the same. We can't leave imaginary i's in the denominator. So what we're going to do is we're going to multiply fraction by complex conjugate. And this is going to be the complex conjugate of the denominator. Okay, so we're going to multiply it by the complex conjugate of the denominator to eliminate the i's. So, for example 5, the complex conjugate of the denominator is 3 plus I. So we're going to multiply the top and bottom of the fraction by that. Okay, so notice that these are all sort of combined things that we're adding and subtracting, and I sort of want you to notice that because what we're going to have to do is we're going to have to FOIL on the top and FOIL on the bottom. So let's go ahead and do that. So if I FOIL the top, I get 15 plus 5i plus 3i plus I squared. On the bottom, I get 3 times 3 is 9. So 9 plus 3i minus 3i, and then minus I squared. All right, so let's simplify this. So the top, we will combine the i's to get 8i, and then remember, anytime we have I squared, we have to eliminate it by plugging in -1. On the bottom, notice that my 3 i's are going to cancel, and I get 9 minus, and I'll plug in -1 for I squared for that one as well. Okay, so now notice I don't have any i's in the bottom. That's good. And then on the top, I don't have any I squared. So now this will become 15 minus 1 on top, which is 14, plus 8i over 10. And then to put this in the a plus bi format, all we're going to do is separate the fractions. So that 10 is going to go to both the 14 and the 8i. So we separate it. And then now we can actually simplify these fractions. So we will get 7 over 5 plus 4 over 5i. Okay, and again, that last step is just getting it into the a plus bi format. Okay, so let's do example 6. Okay, so this particular term is 0 plus I, so its conjugate is 0 minus I, which is just -i. So we'll multiply top and bottom by -i. Okay, so now I'm only multiplying one thing. So I don't necessarily have to FOIL, all I have to do is distribute, so that's kind of nice. So this is going to be -3i minus I squared all over -I squared. Okay, and then we can just simplify this. So -3i, I squared just go to -1. Okay, so then I get 1 minus 3i. So again, I'm just kind of rearranging the terms to get it in the a plus bi format, and that's just over +1. So technically my answer is just 1 minus 3i. Cool. Okay, so for the next 2 examples, for example 7, I've done 2 of these, so I really want you to pause the video, or you can keep going on the video and then come back to it, but I really want you to try example 7 on your own, just so that I can make sure you're understanding how this is all working. And then for example 8, I actually kind of want to see where you are with this concept, so I actually want you to attempt this one on your own as well. So basically, you're going to use the quadratic formula, and if you remember, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. And I want you to sort of use this, and you're going to get a negative underneath the radical, which means that you're going to have to simplify it to I. But I sort of want to see where you are and kind of gauge, and if you're struggling or having any questions, then you can feel free to ask me. So again, this section is highlighting, complex numbers, what they are, how to add, subtract, multiply, divide them, and then sort of if I then apply them to something like solving a quadratic using the quadratic formula, how does that work as well? So please do examples 7 and 8. Okay, I want you to then check your answers with me. After you're done with that, you can start the 2-1 homework. Okay, thank you.